everyone and welcome back to Study Room. In the previous lecture, we talked about polyhedrons, and in today's lecture, we will be talking about the different members of the polyhedron family. So let's get started. The first on the list is prism. So a prism is a polyhedron whose base and top is made up of congruent polygons, and the other faces, that means the lateral or the side faces, they are made up of parallelogram. So let me give you an example of a prism. A cube is an example of a prism. Why? Because I told you that in the prism, the base and the top will be made up of congruent polygon. In a cube, the base and the top is made up of a congruent polygon. And what is that polygon? The base and the top is made up of a congruent square. So here, in a cube, the base and the top is made up of a congruent polygon, that is a square, and all the other side faces, the four lateral or the side faces, they are made up of parallelogram. Again, another example of a prism that we have over here is this one. This is the usual glass prism that you might have even seen in your practical labs. So in this usual glass prism, this is also known as a triangular glass prism or simply a triangular prism. So in a triangular prism, the base and the top of the prism is made up of congruent triangles, and all the three side or the lateral face is made up of parallelogram. The next member of the polyhedron family is a pyramid. Now, a pyramid is a polyhedron whose base is a polygon family. Like it is a shape of a polygon family. It can be of any number of sides. It can be a triangle, a rectangle, any quadrilateral, even it can be of 5 sides. So the main thing is that the base should be a polygon of any number of sides, but the lateral faces or the side faces should be triangles. And these triangles should meet at a common vertex point. So a pyramid is a polyhedron with a base of a polygon of any number of sides, and the lateral faces should be a triangle that meets at a common vertex. Okay, so that's a pyramid. And here we have been given a figure. In figure number 1, the base over here is a polygon of 4 sides. So it's a quadrilateral. And in this case, this is also a pyramid. The lateral faces are triangle meeting up at a common vertex A. But the base over here is a polygon of 3 sides. That means the base over here is a triangle. Now that I have taught you 2 types of polyhedron, one is prism and the other is pyramid, I'll teach you how to name these prisms and pyramids. So, let me tell you one thing, that the prisms and pyramid, they are named after their bases. So, when I tell that I have a hexagonal prism, what does that mean? A hexagonal prism means that the base and the top portion of that prism will be a hexagon. That means it will be a 6-sided polygon. So a hexagonal prism is a prism that has hexagon as the base. Next up, we have a rectangular prism. As the name suggests, rectangular prism means the base of the prism will be a rectangle. So whenever we get a prism, we have to look at the base, the shape of the base. If the shape of the base is a pentagon, so that will be a pentagonal prism. If the shape of the base is a hexagon, that will be a hexagonal prism. So, the main important thing is that the shape of the prism depends upon the base. If we have rectangle as the base, so that prism will be known as a rectangular prism. Now, the same thing we have with the pyramids as well. The pyramids also, they are named after their bases. I told you that in case of pyramid, the base can be a polygon of any number of sides. So, a triangular prism means that the base of this pyramid, a triangular pyramid. A triangular pyramid means that the base of this pyramid will be a triangle. Again, if we have the base of the pyramid as a square, so it will be known as a square pyramid. So, a square pyramid is a pyramid with square as its base, and a triangular pyramid will be a pyramid with triangle as its base. Now that I have taught you what are faces, edges and vertices, let us fill the boxes given below on the basis of the information that has been provided. Over here, it is written that V stands for the number of vertices, F stands for the number of faces, and E stands for the number of edges. So, based on this information, we have to write the number of faces, vertices and edges of the figures that are given below. The very first figure that has been given to us is a cuboid. Now, we have to first write f. That means the number of faces of a cuboid. In a cuboid, we have in total 6 faces. Now, the number of vertices of a cuboid is 8. And the number of edges that a cuboid has is 12. Now, another thing we have over here is f plus v. That means the number of faces addition to the number of vertices. The number of faces when added to the number of vertices, that means 6 plus 8 gives us 14. And here we have e plus 2, that means the number of edges plus 2. That means 12 plus 2, which in total gives us 14. The next figure that we have is a triangular prism. In a triangular prism, we have 5 faces in total. So I'll be writing the number of faces as 5. The number of vertices is 6. And the number of edges is 9. Now, if I calculate f plus v, that means the number of faces plus the number of vertices, it gives me 5 plus 6, that is 11. And if I calculate e plus 2, that means the number of edges plus 2, it again gives me 11. Let us try solving some more examples of the same type. So here we again have a triangular pyramid. So in a triangular pyramid, the number of faces are 4. I hope it's very evident from the figure. Now the number of vertices in a triangular pyramid is again 4. And the number of edges that a triangular pyramid has is 6. Now when we add up f plus v, we get 4 plus 4, that is equal to 8. And when we add up e plus 2, we get 6 plus 2, that is again equal to 8. In the next question, we have pyramid with a square base. So a pyramid with a square base will have 1 square face and then 4 triangular faces. So in a pyramid with a square base, in total we have 4 plus 1, that means 5 faces. So we have 5 faces. The number of vertices is also 5. But when it comes to the number of edges, we have in total 8 edges. When we add up f plus v, this gives us 5 plus 5, that in total sums up to 10. And e plus 2 gives us 8 plus 2, which is again equal to 10. Another example that we have over here is a prism with a square base. Now, look at the figure. Can we not say that a prism with a square base is again a cube? So, the number of faces will again be 6, the number of vertices will be 8, and the number of edges will be 12. F plus V gives us 6 plus 8, which equals to 14. And E plus 2 gives us 12 plus 2, which is equal to, again, 14. Next up, I'll be teaching you Euler's formula. Now, what is Euler's formula? Euler's formula is that F plus V minus E is equal to 2. Now, is it similar to something that we did? Yes. In the previous examples, let me show you one of the previous examples that we did. In the previous example, we had over here F plus V gave us 14 and E plus 2 gave us 14. So from here, can we conclude that F plus V actually gives us E plus 2? From here, if we take E to the left hand side, so it will give us F plus V minus of E equals 2. And this is nothing but the Euler's formula. So we can say that what we have done till now can be concluded as the Euler's formula. Now wait, I'll explain it to you. So in Euler's formula, we have F plus V minus E is equal to 2, and this is applicable for each and every polyhedron, where F stands for the number of faces, V stands for the number of vertices, and E stands for the number of edges. And this relationship between the number of faces, number of vertices, and the number of edges gives us the Euler's formula.